Hey, what's up guys? Swift Coding back here with another video. Today I'm going to be showing you how to just do a basic rollerball movement in Unity 3D. Okay, so let's start with making the ground a plane. You can select that from the hierarchy. Let's put it a bit down and let's rename it plane. I meant ground. Now let's make our character, which is a ball. Let's make a sphere from the hierarchy, call it a player. Now there are a few components we need to add, well only one. We need to add a rigger body, so it has gravity and we can move it. So you go onto the player, you press add component, search up rigid body. Now not 2D because we're not in a 2D template, we're in a 3D, so we just do rigid body. Okay, now let's add a script. Let's call it player movement. Now press create and add. Now you need to right click it and press edit script. Now depending on what programming software you use, I use Visual Studio. Most of you guys will too, but some of you might be doing MonoDevelop, but it's still going to be the same. So just wait until it loads. Okay, so now I finished. Also, with the rigid body, what it does is that you can add force to it, which what we're gonna be using instead of just translating. So it's not all boring, it's gonna be more natural with gravity, and we're gonna add force when we move. We're also gonna move with WASD. Just wait until it loads. Okay, so once it loads in, you're going to have something that looks like this. Now we need to add some public variables. The difference between public and private variables is that private, for example, if I had a private integer, if I had a private int called a, is 5, you won't be able to access it from Unity, whereas you can only access it in the script. But if I had a public int 5, I meant a equals 5, you can set the value from Unity and it is visible to all scripts. So the first public variable we're going to use is going to be a float, and we're going to call it speed. See, now we're not going to actually assign it to a value because we can easily just do that from the hierarchy, from the inspector in Unity. So once we have that, we also need to assign the rigger body. This is what we're going to be using to add force. Now we don't need to make it public, we can still make it private because it is still part of the same game object. So rigid body, let's call it RB. Now RB equals this dot get component equals this dot get component, then rigid body. So it's gonna get access to the rigid body that is in this game object. So now this update is called everyone's frame, so it's you can just think of it as just a normal like loop. It's just going forever. You can just think of it like that. There's also void fixed update. It's better when you're using more physics, movement, and calculations and stuff. But update is better wise. I use it more. So let's do float, then x equals input dot get axis horizontal. That might seem like, whoa, you Swift coding, you just wrote like a line. I didn't understand one thing of that. Well, first of all, I just assigned a float and input. If you go into Unity, you'll find, if you go into edit, then you go into project settings, you'll find something called input. Now, horizontal refers to the left and right arrows and D and A, because those are the like default keys to move left and right on the X angle, and that's the exact same with Y. If I do input dot get axis vertical, it's on a vertical axis. So those are the names of the axes on the Unity input system. Now, all we have right now are the variables of x and y. We still need to actually assign that to the player's position. So let's make a vector 3. Now you probably know what a vector 3 is. It's just a point. A vector 2 is a point, but in the 2D. A vector 3 is a point, but in the 3D. So it's going to have 3 dimensions, x, y, and z. X and z. So yeah, so vector 3 movement equals, we're gonna assign y as our z, because we're just gonna use w and s to go up, like up and down, but not on the y-axis. Like it's still the y-axis on the keybinds, but not in the actual transform. So equals new vector 3. Now if you ever have trouble, this will pop up when you refer to the function. You can see all of the parameters you can use. Now this is the one we're going to use: float x, float y, float z. We're not going to use float y because we don't want it to fly. We're only going to use float x and z. So for x, we're going to just place x and 0. Let's add f because it's a float, and y. They're simple. Now we still need to add this to the player's transform. So let's make it rb dot add force. So what I referred back to. So now we're going to make the force, which is going to be speed times movement times time dot delta time. Movement is the point we want to move it to. Speed is just how fast it's going to be going, and time dot delta time is just so it makes it go more natural and more like, so it just moves every point. So now that we have rb.addForce, let's just go ahead and press attach to Unity or start. So let's go back to Unity. Let's go check our player. Okay, so what you're gonna see, wait, it's still just running. What you're gonna see is speed equals 0. if you run it, nothing's gonna happen. Watch. It's not moving just because I haven't assigned the speed value yet. Well, I have. It's 0. So 0 speed means you're not gonna go at all. If I have 10, let's see what happens. Very slow. You can see here that it's going very slow. It's rotating on all angles. It's like that. Now let's see what happens if we just times that by 4. It's gonna go 4 times as fast as we just saw. It may be hard to move, but it's very realistic. Now let's make that 100 and see how fast that goes. You can also see the acceleration of it. Like it starts off slow. You can see it's very hard to move, but it's very realistic too. Also, another thing is that the rigid body is what adds the force. So watch the gravity take its place. See, it fell. Now that may seem boring just because you saw it just go all the way down and just drop. It just went still. What we can do to make it less boring is create something. A material is what you can change its color, you can change its albedo, you can tell how smooth it is, what color and stuff. But there's also a physics material, which is like its bounciness, its friction, and a lot more. So let's call it bounce. Let's make that 2, 1. Let's you put it into the sphere collider and then watch it bounce. It may not bounce as bit high though. See, much more realistic. That concludes today's video. Thank you all for watching.